I am Durga Prasad Akal, currently facilitating Kathmandu University School of Education. I teach statistics with the help of Spss. Today, I share idea about how we calculate or how we work independent sample t-test with the help of Spss. First, let us know about the independent sample t-test. The independent sample t-test evaluates the difference between the mean of two independent groups with an independent sample t-test. Each case must have scores on two variables, the grouping variables and the test variables. There are two variables. The grouping variables divide its cases into two mutually exclusive groups or categories, such as mean or women for the grouping variable gender, whereas the test variable describes each case on some quantitative dimension such as verbal comprehension. The t-test evaluates whether the population mean of the test variable for one group differ from the population mean of the test variable for the second group. Basically, the application of this independent sample t-test is used on experimental studies, quasi-experimental studies, and field studies. Now, I'm gonna demonstrate how we calculate independent sample t-test in SPSS. Okay, I have already here a file of or the SPSS icon, SPSS statistics, which is 23 version. I already installed in my desktop computer. I have data already filled. The name of this data file is subfinal.cav. Here are variable view and data view. If I click on data view, then there is data which already filled in this computer, and here is variable view. When I click the variable view, then we can see here like a serial number, name, school type, the type of school, which is labeled here, and the value for the type of schools are the value 1 for community and the value 2 for private. So in independent sample t-test, what I have to test over here, for an example, I want to test teachers support, which is here. I want to test teachers support. That's gone down. Yes, teachers support. This teacher supports is the average teacher supports already calculated. Teacher support scores under these all data concerned with students under the gender of the students. Gender of the students is here, and the value 1 for male gender and the value 2 for female. So I want to test the teacher support, the impact of teacher supports for male and female, what it is different or same. For this, everything's are here on top of this file menu. For this, we have to go in the analyze. Basically, in SPSS, analyze is the heart of the SPSS. Click analyze and go to compare mean. and move to the independent sample t-test. Click on independent sample t-test. We can see like this type of dialog box, independent sample t-test. Here is the test variables and here is the grouping variables. The test variables, okay, reset. The test variable is what I am going to test for different group, because of this is the independent sample t-test. So now let's test the teacher support. Teacher support is the test variable. Now let's test teacher supports for whom? For students, gender of students. If we click here, then it goes from here to here. Now in the highlighted part there is double what? The meaning of what symbol is the gender. How many genders are there? Categories of students. So click on define groups. We already found here the gender, which is in row 6. Gender of students is described by the label column, gender of students, 1 male and 2 female. These are the defined group. So in group 1 we can type here 1, and in group 2 we can type here 2. So this define the gender of student. Then press continue. We define groups. Instead of that question mark symbol, now we can find here 1 and 2. We can go to the option as well. The confidence level percentage is 95%, and exclude a case analysis by analysis. Can click continue. Now bootstraps, we don't need bootstraps at this moment because of this is for the different category, number of sample 1000, so we can ignore it, or we can click continue. We can click continue. After this continue, we can press OK. So this is the output table, the output of Spss. Here get file is users Durgadakar desktop thesis embedded thesis final.save. The file which is used by the Spss is inside of this computer system. So I use independent sample t-test under the gender. These are the information which we use the previous dialog box. And the structure of output for that t-test is gender of the students, the male and female, teacher support, and 123 respondents are there for male and 133 respondents are there of female, or 133 female and 123 male respond these inquiries or information about teacher support. Sorry. For male, we can see mean value is 3.66, and for female mean value is 3.89. is quite similar, and the standard deviation is quite similar. So the teacher support for male and female is significantly different or not different. We cannot say simply. We can say after analysis this output table. First we have to look Levin's test for equality of variance. Here is the F value for the Levin's test for equality of variance, and significance value which is 0.023. Okay, this figure significance value which is 0.023. What does it mean? why we select this value. Leavens test, from the Leavens test, we select equal variance, assume or not. If the Leavens test is significant, we may conclude that the equality of variance assumption is violated. That means equal variance are not assumed. At the level of confidence 95%, the significance value alpha is 5%. The value of alpha is 5% is 0.05. Now here the significance values from the Leavens test is 0.023, which is less than 0.05 or which is less than 5%. If significance value is less than 5%, then we select this equal variance are not assumed. This one. If this significance value is greater than 5%, then we say or we take the all informations for t-test, degree of freedom, significant two-tails value, mean difference, these all value we take from the first row, that is we assume that equal variances are assumed. But here in our condition, in the Leavens test for equality of variance, we have 0.023, which is less than 0.05, which is less than 5%. So we can say there is equal variance is not assumed. So we are taking the information of t, degree of freedom, significance two-tail value, and these other things from second row. Okay. Here in two-tail test, are they different or not different? That's why this is the two-tail test. The degree of freedom is 246.746. The value of t is minus 2.660, and the significance two-tail value is 0.008 or 0.008. As previous dialog box, we input there the confidence level is 95% and the significance level is 5%. That's why this value 0.08 is obviously less than 0.05, or this significance or p value is less than 5%. If this significance value is less than 5%, or null hypothesis is rejected. We cannot retain null hypothesis because of this significance two-tail p value is less than 5%. If this value is greater than 5%, then we retain null hypothesis. But in this case, in this output, we reject null hypothesis. That is the final decision from this table or from these significant two-tail values. Okay. So in our case, the null hypothesis is rejected. Thank you very much for watching this video.